Alright, so this is exam 3, problem 2 from the test. This is the most missed one. So here you can see that you have a circuit. And for the first scenario, you're going to have the switch closed for a long period of time, and it wants to know the current at every single point. So point A, B, C, and D, as well as E. And if you look at it, if the switch closed, you're not going to have any current running through the small circuit over the capacitor. That way, you know that A, B, D, and E are the same, and you know that point C, the current's going to be 0. And using loop rule, we know that using node rule, we know that the EMF over the summation of those resistors is going to give you the current for A, B, D, and E, and that's just the EMF for R1 plus R2. For the point C, as I said, there's no current running through that capacitor because it's in the steady state, so that's just going to be a current of 0. Now for the charge on the capacitor, no, that's just the capacitance times the potential change, and we can get the potential change with I times R. R being R2 because that is the resistor in the circuit that contains the capacitor. That's going to be EMF for R1 plus R2. And that the R is going to be R2, as we said. And now we can just plug that guy here in for the charge. That's just capacitance times EMF over R1 plus R2 times R2. And that right there gives you the charge on the capacitor. And there you have it. So for part 2 of the problem, it wanted to know immediately after the switch is open what the charge would be. Now, we know if the switch is open, the circuit with the battery in it is not going to be complete. That way we know that the current's only running through the smaller loop. That means at points A, B, C, and D, the current's going to be 0. And we know that the potential change in the capacitor is equal to the potential change of the resistor. That way we can get the potential change in the capacitor is equal to the current times the charge or the resistance of the second resistor. That gives us a potential change in capacitor of EMF times R2 over R1 plus R2. Now if we want to get the potential change of A, B, C, D, that's going to be 0 as we said. And C and D, you're going to EMF all over R1 plus R2 times, now Q is the same because it's immediately open, so the charge doesn't have time to change. For the second one, it wants to know after a long time the switch is open, what will the charge be? So if the switch is open for a long time, we know that the capacitor has plenty of time to use up all of its charges and essentially get discharged throughout the circuit. And that way we know after a long period of time the charge is going to be 0 and the current is going to be 0 everywhere in the circuit. And that's all there is to it because there's no other source.